Finding extrema on an interval. Your maximum and minimum values on a closed interval basically are the highest or the lowest points. Your minimum point is smaller than any of the other y values or the f of x values. Your maximum point is larger than any of the others. Your maximum and minimum points on a closed interval sometimes will occur at the endpoints of your interval. Sometimes they will occur in between. Now, you'll notice here we have a maximum that's at an endpoint. Here we have a minimum that's between our interval, somewhere in between. Here, this would be referred to as a local maximum. It's a maximum just compared to the area that's around. But this is our absolute maximum, this is our absolute minimum. Looking in the center here, we have no maximum because it's an open interval. Both of these are not included. So we have no maximum, but we still have a minimum. Over here, we still have a maximum at the end of our closed interval. Here, you'll notice that your minimum, it's an open point, so it's not included. Now, your local minimum is just a minimum compared to the points around it. So this one right here in the center is also a local minimum in addition to being your absolute minimum. Your local maximum is just your highest point in that neighborhood or the points close to it, not necessarily the largest of the whole function. Now, to find your extrema on a continuous function on a closed interval, you want to find your critical numbers. Your critical numbers or critical points are down here in red where your y value or your derivative is 0 or your derivative does not exist, meaning it's undefined. In addition to evaluating your function at the critical points where your derivative is 0 or undefined, you also want to evaluate it at the endpoints of your interval. The least of these values when you evaluate it is your minimum. The largest of all these is your maximum. Now, you'll notice these pictures down here. Here we have a maximum, and that's occurring when we have a horizontal tangent, when your derivative is 0. Here we also have a maximum, and it's occurring at a cusp, where your derivative is undefined. Your max and mins will always either be at an endpoint or where your derivative is 0 or undefined. So let's go ahead and try to find our maximum and minimum values here. We have our closed interval from -1 to 4. So we're going to start off by finding our derivative, and all we have to do is the power rule, putting our exponent down in front, decreasing your exponent by 1, and we end up getting this. Now, for simplicity, since we're dealing with fractions as coefficients and exponents, you may want to pull out your greatest common factor. In this case, we did not, but some people may prefer that approach. If you did choose to pull out your greatest common factor, you could pull out a 5/3, an x to the -1/3, and then you would be left with a 2 minus an x for your derivative, if you pulled out your greatest common factor. Whether you pull out your greatest common factor or set it equal to 0 and solve it, it doesn't really make a difference. Here I set it equal to 0, took my one fraction to the other side. Then all we have to do is a little bit of cross multiplying and dividing, and you'll notice we get 2, which is very similar to what you would have gotten up here, because you would have had an x minus 2 on the top over a 3 and then the cube root of an x. The top would still be multiplied by 5. And when your derivative is equal to 0 is only when the top is. And so then that's just your 2 that we had down below here. Also, your critical points are where it's undefined. It's undefined what causes the bottom to be 0. And we also need to test our endpoints. That was the -1 and the 4. We're going to go ahead and check our critical points. So we're going to try to find f of 1, f of 0, f of 2, and f of 4. Remember, in trying to evaluate these, that you have to plug them back into your original function. You don't want to use your derivative. You use your derivative to come up with the critical points, but to evaluate them, you plug it back into your original function. When you plug in -1, you get 6. Plug in 0, well, that's pretty easy, you get 0. Plug in your 2, you get 3 times the cube root of 4, which for evaluating it to your 0 and your 6 you have up here, you may want the decimal approximation. Plug in your 4, your other endpoint, which is 2 times the cube root of 2. And there's the decimal approximation. Now, the largest of all these is your maximum. And well, of course, that's the 6. So your absolute maximum occurs at x being -1, your y being 6. So it occurs at the endpoint of your interval. The smallest of these highlighted ones is your minimum. And well, that, of course, is 0. So your minimum, in this case, is the origin.